Hello, today I want to talk about something like non-uniform chance. So usually when you doing the random chance, usually you will using a function like this, np random uniform, and you will get the value from range to 0, from 0 to 1 like this. And the chance that the value from 0, for example 0 0.1, 0 0.2, 0 0.3, and so on until 1, and there's a infinity series in there that is set. So for all of that infinity number, the chance that some number will be chosen when I execute this function is set. But what if there's a case that you want that you know that the chance of the something that is chosen, or the value that is pop out from the function is not uniform. So for example, I will show you this. So actually I create this function to simulate the error from when forecaster write a code method like this. So usually when someone doing a method, sometimes they will do a mistake, like example there's no z in here, or for example the digit in the win code in here, there is missing number, or there is a additional number, and the code will be invalid. And when the mistake happen, most probably the mistake is only one. For example, in one case here, the user missed the z in here, or in another case the user missed t in here, so he just write 05005k. But there's a chance that the mistake is two. For example, he missed T in here, and also he missed Z in here. And there's also chance that there's three mistakes. But in my experience, the most probably when user doing a mistake, when he write a code, there's only one mistake. It's the most probably. But there's also two mistake or three mistake and so on. But the probability is very little. That's why here I want to write a code to simulate that chance. So yeah, so I will just show you here. So in here, as you can see here, the probability of the system will choose 1 is 30%, and for the choose 2 is it's between 20% and 25%, and so on. And the function is here. The main function that I use for this is the sigmoid function. If you don't know of the sigmoid function, it's like this. And in here, it's just to make an array of probabilities, and this function is to use that probabilities to choose from this distribution of probabilities. See, you can see here. And actually, you see, the graph is like this, right? But in my experience, I think the chance of user when he or she doing a mistake, it's not just 30%, it's something like 60 or 70% if he doing a mistake and it's only one mistake. And to adjust that, we can set it in here. It's fairness. And now maybe this function, maybe I just reinvent the wall. Maybe there's already robust function in numpy, but I can't find it. Fairness in here is 1, Let's see what if we set it as 3. And as you can see here, the probability of if the user make mistake and it's only one mistake is around 60%, and two mistakes is around between 20 and 30%. Let's increase the number, sample 5. And as you can see here, the chance of when the user make the mistake and it's only one mistake is increasing, right? And yeah, the chance of two mistake is decreasing drastically. And I think for my case, this is the matching fairness. And that's it. This is just, I know this is just, maybe some of you find this absurd, but for me this is very useful, because this is very useful for my case, because I want to simulate the chance of user when he or she doing a mistake, when he or she write the code in meta or another of met code. And yeah, that's it. Bye.